last class we had studied about the collision, inelastic collision and elastic collision. We have seen. We have also studied little bit about the term that is known as coefficient of restitution. So, what was the coefficient of restitution E? That was equal to the final velocity, means velocity of separation divided by velocity of approach. Is this okay? Mod. This is the coefficient of restitution E, isn't it? Is this all right? As for example, suppose there is an object A and B. B is moving in this direction with 5 meters per second, and A is moving in this direction with 10 meters per second. After collision, A starts moving with 8 meters per second, and B starts moving with 6 meters per second. Hope you understand. So what is the coefficient of restitution E? So coefficient of restitution is velocity of separation. So what is the velocity of separation now? No. This country. This is 6, suppose, and suppose this is 8. So can you say me what is the velocity of separation? They will separate with a relative velocity of 2 meters per second, isn't it? And what is the velocity of approach? So their relative velocity is 5 meters per second. So velocity of approach is 5. So coefficient of restitution will become 2.2 by 5, that is equal to 0.4. Hope you understand. Is this all right? So now do one more question. Suppose there are two objects, its mass is 2 kg, and here there is object whose mass is 4 kg. This is going in this direction with 10 meters per second, and this is moving in this direction with 5 meters per second. After collision, this 2 kg object starts moving with 4 meters per second, and this 4 kg object starts moving with 6 meters per second. Find coefficient of restitution and loss of energy. Just wait 1 minute. Just wait. Let me think. This is 15 by 2 meters per second. Is this all right? 15 by 2 meters per second. We can't take any values, isn't it? Find loss of energy and coefficient of restitution. Why we had not take any values? Why we correct it? Because momentum has to conserve, isn't it? So I have to present the data. I have to give data according to the momentum conservation. Now try to do it. Do it first. Okay, so let's say it. So what is the velocity of approach is equal to velocity of separation is 15 by 2 minus 5, and velocity of approach is 10 minus 5. So that will be equal to 5 by 2 divided by 5. So it will be equal to 1 by 2. This is the coefficient of restitution. So what is loss in energy? So loss in energy delta K E is equal to K final minus K initial. Sorry, this would be K initial minus K final. Is this all right? This is the loss of energy. So what is K initial? K initial is equal to half into mass is 4 into 25 plus half into 2 into 100 as 10 square is 100. This is the initial kinetic energy minus final kinetic energy is half into mass into v square plus half into mass into velocity square 225 by 4. Is this all right? So if you calculate it, this is 2, so this is 50 plus 100, that is 150 minus 2 cancelled out. So this is 25 plus 4 cancel out. So this is 112.5. So 150 minus 137.5, that is equal to 12.5. Is this okay? 12.5 joule is right answer. Hope you understand. Is this all right? Good. Now, perfectly inelastic collision. Perfectly inelastic collision. So suppose two object M1, M2. This is moving with U1, U1, and this is moving with U2. So U1, if U1 is greater than U2, then they will collide to each other. So if the collision is perfectly inelastic, what does it mean? Objects stick to each other, stick to each other after collision. If after collision object gets stick to each other, then such type of collision is known as perfectly inelastic collision. Hope you understand. Is this all right? That is known as perfectly inelastic collision. So suppose M1, M2 is going and U1 is will stick to each other. Have you seen such a collision when the object gets stick to each other? I think you have seen it, isn't it? If you put a mud, if you throw a mud on the vehicles which is already moving, that is the mud get a stick to the vehicles. That is a type of perfectly inelastic collision. Is this all right? Okay, good. So now U1 and U2. So this object will stick to each other. So its mass will become equal to M1 plus M2. And after collision, it moves with a common velocity V, because if the object get stick to each other, they have to move with the common velocity, that is V, isn't it? So what you need to do, you need to do the momentum conservation. We can conserve the momentum in all type of collision, isn't it? So M1 U1 plus M2 U2 is the initial momentum, and that will be equal to the final momentum, that is M1 plus M2 into V. Hope you understand. So from this place, you will get the velocity that is equal to velocity is m1 u1 plus m2 u2 divided by m1 plus m2, isn't it? This is the final velocity of the combined object. Hope you understand. Is this all right? So this is the combined velocity of both objects after perfectly inelastic collision. Is this all right? Copy it. Don't try to remember these formulas. Only try to remember the formula of elastic collision that we had studied last time. Is this all right? Now, so one more thing. Can you tell me what is the very important thing? What is the coefficient of restitution or perfectly inelastic collision? Perfectly inelastic collision. Can you tell me? So for perfectly inelastic collision, what is the coefficient of restitution? Coefficient of restitution E for the perfectly inelastic collision will be equal to 0. Why? Because definition of E is velocity of separation. Separation divided by velocity of approach, isn't it? And if after collision they stick to each other in perfectly inelastic collision, then velocity of separation will become equal to 0. That's why E value is 0. Is this okay? They are not separating to each other, so velocity of separation becomes 0. So coefficient of restitution becomes equal to 0. Is this all right? So one more important thing about the coefficient of restitution is all the collision in universe is in between perfectly elastic and perfectly inelastic. So coefficient of restitution will be between 0 to 1 always. 0 for perfectly elastic, sorry, perfectly inelastic, and 1 for perfectly elastic collision. What do you mean by perfectly elastic collision? Perfectly elastic collision means the velocity of approach and velocity of separation are same, isn't it? So perfectly elastic collision. For perfectly elastic collision, that is 1, and for perfectly inelastic collision, that is 0. Is this all right? Hope you understand. Good. Do one question on it. Suppose this is 5 kg object, and suppose this is 10 kg object. This is moving in this direction with 10 meter per second. This is moving in this direction with 2 meter per second. If collision is perfectly inelastic, if collision is perfectly inelastic, then find final velocity of object. Also find loss in kinetic energy. Is this all right? Do it fast.
So, okay, let me discuss. Just wait a single minute. So, let me discuss. Hope you did it. So, mhm. So this is perfectly inelastic collision. So after collision, they stick to each other. So its mass will become equal to 15 kg. Isn't it? 5 plus 10, that is equal to 15 kg. And they starts moving with a common velocity v. So if you do the momentum conservation, initial momentum will be equal to final momentum. What is initial momentum? 5 into 10 minus 2 into 10 is the initial momentum. What is final momentum? 15 into v is final momentum. So that is equal to 50 minus 20 is equal to 15v. Is this okay? So from this place we will calculate v. V is equal to 30 divided by 15, that is equal to 2 meter per second. Is this okay? So after perfectly in elastic collision, they are going with 2 meter per second velocity in forward direction. What is loss in kinetic energy? So loss in kinetic energy is equal to kinetic energy initial minus kinetic energy final. What is initial kinetic energy, student? Half into 5 into velocity square plus half into 10 into velocity square, that is 4.
minus what is initial kinetic energy, half into mass into v final square. V final velocity is 2, 2 square is 4. So this is 50, this is 2, this is 2. So that is equal to 250 plus 20 minus 30. That is equal to minus 10. That is equal to 240 joule. Hope you understand. So loss in kinetic energy will be equal to 240 joule. Is this okay? That will be the answer. Is this all right? Copy it. One more question, then we will start a new topic.
Sir, inequality left, sir.
Okay, copy it.
Thank you, sir.
Okay.
Thank you.
So let's yeah, do another question. Another question is that suppose this is 2 kg. This type of question used to come. This is moving with 10 meter per second, and another object of mass, suppose 4 kg, that is moving in this direction with 5 meter per second. They collide each other. They collide each other, and and after collision, velocity of 2 kg object and velocity of 4 kg object, you need to find these two, v1 and v2, if E is equal to coefficient of restitution, E is equal to 1 by 2. Is this okay? Try it. Do it fast. Okay, student. So first you need to do the momentum conservation. So P initial will be equal to P final. So initial momentum will be equal to 2 into 10 plus 4 into 5. And final momentum is equal to 2v1 plus 4v2. So that is equal to 20 plus 20 is 40. That is equal to twice v1 plus 4v2. So v1 plus 2v2 will be equal to 20. This is the first equation, isn't it? This is the first equation. Now, coefficient of restitution we know is the velocity of separation divided by velocity of approach. Velocity of separation means if they are separating, v2 is greater than v1. So v2 minus v1 divided by velocity of approach is 5. You can see it is equal to 1 by 2. So from this place you get a equation 2v2 minus 2v1 is equal to 5. That is the second equation, isn't it? So now subtract them. If you subtract them, what will happen? This will be minus, this will be plus, this will be minus. So this one and this one will be cancelled out. So that will become 3v1 is equal to 15. Is this okay? So v1 is equal to 5 meter per second. Hope you understand. Now calculate the value of v2. So twice of v2 is equal to 15. So v2 is equal to 15 by 2 meter per second. So v1 is equal to 5 meter per second and v2 is equal to 15 by 2 meter per second. Is this okay? That is the correct answer. Okay. Now copy it first. So now the next topic is impulse. What do you mean by impulse? What do you mean by impulse? Impulse basically is mathematically integral f dot dt is impulse. Mathematically impulse is written by j. J is equal to f dot dt integral. Is this okay? Force dot time. So this is a vector quantity. This is not a dot product. Time is not a vector. So this is simple multiplication. This is impulse. This is the mathematical definition of the impulse. But theoretical definition of the impulse means a sudden force, sudden huge force, isn't it? That is the impulse. Sudden change in momentum. Change in momentum is impulse, isn't it? Is this all right? Suppose so sudden change in momentum means if huge amount of force acts in very less time duration, very less time duration, then such type of thing is known as impulse. Is this okay? Such a force is known as impulse. Hope you understand. Is this all right? Good. So that is impulse. Suppose what you did, suppose there is a hammer with you. You have a hammer and you strike a hammer on the surface. Then that force is the sudden force. Isn't it? That force was a sudden force. Isn't it? And that sudden force was huge amount of huge amount. Is this okay? So huge amount of force is acting for a small interval of time. Is this okay? So such type of force is known as impulse. Hope you understand. So now, suppose if force of 10 to the power 4 Newton acts on a surface for 0.2 second, find impulse. Find impulse. Do it fast. Now question is, this is of mass 2 kg. This goes with 100 meter per second. And after colliding to the surface, this reflect back with the same velocity 10 meter to 100 meter per second. If time of impact is 0.1 second, then find impulsive force. Do it fast. So do it, a student. So impulse is basically force 10 to the power 4 into time is 0.2. So that is 0.2 into 10 to the power 4. That is equal to 2000. Isn't it? 2000 Newton second. This is the impulse. Now, what is happening here? Air momentum is in this direction. And this is equal to 200 kg meter per second. And final momentum in this direction, that is equal to 200 kg meter per second in this direction. So what is change in momentum? P final minus P initial, that is equal to 400 kg meter per second. Is this okay? This is P initial minus P final, that is 400 kg meter per second. Hope you understand. Is this all right? So this is change in momentum. Change in momentum and change impulsive forces. So first of all, try to find force. So according to Newton, what is the force? Force is change in momentum by time taken, isn't it? And if you multiply force into time, what you will get? Force into time is impulse, isn't it? So impulse J is equal to change in momentum, that is equal to 400 kg meter per second, or you can write it Newton second also. So 400 is right answer. Hope you understand. Is this all right? So, okay, this chapter has ended. So I think there are 5 to 10 minutes left. So let me end the class today. Okay. For today, let me end the class. And in next class, with a fresh mind, we will start a new chapter that is known as rotational mechanics. Rotational mechanics. This chapter is very, very famous. And generally, a student of class 11th are scared of this chapter, isn't it? Out of 100 student, 95% student used to leave this chapter, isn't it? They understand that this chapter rotational mechanics is not for a normal student. This need a lot of brain, but why they think so, I does not know, isn't it? So we should not think like that, that rotational mechanics we can't study and we can't understand. This chapter is very, very basic, if very, very good chapter, little vast chapter and little important chapter. There are many terminologies used. Till now, whatever we have studied in mechanics, all together we are going to use in rotational mechanics. Hope you understand. Till now we have studied kinematics, that we are going to use in rotational mechanics. Till now we have studied energy conservation, that also we will do in rotational mechanics. We are going to use momentum conservation in this one. We are going to use friction concept in this one. We are going to use free body diagram, Newton's laws concept in this chapter. So this chapter contains a lot of varieties, isn't it? That's why this chapter becomes difficult for a normal student. But if you break this chapter into many parts and try to observe that part and try to study that, it will take little time, it will take little more work, isn't it? More dedication it needs, but this chapter can be understood easily. So it's my personal suggestion to you all, before attending next class, please revise the concept we have studied till now. Till now, whatever we had studied, please try to revise that. Is this okay? Just go through the class note. Just go through the class note once, take a proper revision, and then we will return to the rotational mechanics in the next lecture. Okay, good. Thank you. Bye. Take care.